So today we're going to see we're going to do things a little bit different. What we're actually going to do is create a new behavior, but we're not gonna add it just yet onto our whole behavior tree over here, but we're going to, since this is going to be pretty much a lot of code, but you don't want stuff to be cluttered up, so we're going to separate the part where we create the whole behavior, and on a later video we're going to see we're going to see how we can make the enemy decide what stage to go and do all that. Now, the behavior we're going to create is, of course, when he's attacking, we do not want him to sit over there, just like that. So we're going to create a cover behavior, which, now, do not mind about the sliding, because he is on the aiming state. Okay, since we're going to be calling them later from the whole logic from inside the script, and I will not be changing the stuff directly from over here, this wouldn't happen. Okay, so what we're going to do is create the cover behavior, which in turn goes searches for cover, okay, and then makes the character go to that cover, and when he reaches, he's going to be attacking his current target. Now, of course, this might seem simple, but of course nothing is that simple. Right from the start, we have a few problems that we should also think about. Okay, so for instance, how do you decide from which part is the correct cover for the enemy to stay? Okay, another thing you can also that there is also a problem if what happens when the cover is over here, is away from the player. Okay, so for the enemy, for the unit to go and hide behind cover, what happens if he has to cross from his target? Okay, and we will see how to do checks for all that. One more thing is that what happens when we have multiple enemies instead of one. Okay, and they want to go all of them together, and we want them all of them together to take cover, and let's do that. Okay, we create cover, okay, and you see that they go and they attack, and if I select the other character over here, then you will see that nothing is going to happen, but that's not true. We have some console behaviors that we are seeing from over here. Now, the way we are actually doing this is we create these objects that they are the cover position. Okay, and these objects have a logic script inside that has you can call them slots if you will. Okay, so we're not just sending them behind towards that object, we are actually sending them on the actual slots we're going to use. And of course we have slots from the back of the cover position, and slots from the front. And of course we have the models over here, we're not going to care about that. And I've also added a nav mesh obstacle. You do not have to add a nav mesh obstacle. If you make it static, then the nav mesh is going to bake around it. Now, let's start with these cover positions first. Now, I've separated the front positions and the back positions, because this way we will have fewer calculations. You can add them all inside one list. Okay, there is no problem with that. But of course you will have to do later more some more calculations to validate that you are actually in a position, in a cover position. So the list we see here is a list of cover base. Okay, and the cover base is the base class where all the positions are of this class, and then the two things that we want to use is we're going to have a boolean to say that if it's occupied, so if there is already a unit there, then we cannot use that cover position. Okay, now we have lists and not just simple transforms and stuff like that, because you might have a cover object that is twice as large. Okay, so we keep things modular, and you can be pretty much really flexible with this. Okay, and then we want the actual transform position, which is the actual position we're going to send the unit. Now the units as you see over here, the slots where they can hide behind, as you see over here, they are just simple empty game objects. Okay, we add the component to our, we need to add it on the game object that has the collider. Okay, otherwise we won't be able to, he is not going to be able to see that this is a cover position. Okay, and we do it this way, and then we create the front position and the back positions, how many he can actually take cover, and then we add the empty game objects. Now let's go to our attack behavior. Now we remember on the previous part we refactor our code, and you will see here why we did that. So if I go now to my attack behavior, you will see that I've added a lot more stuff, and we do not have everything cluttered up inside only one script. Okay, now before we go into the attack behavior, let's go do the few changes we have to do on the enemy AI, and that of course is add the cover into our enum for our AI states, and then on our switch come over here and say, if in case the AI state is the cover AI state, call from the attack behavior script the cover behavior function. And of course we haven't created the attack cover behavior yet. Well, I have, you haven't. Okay, so we will go and see over there. Now on the later part we're going to see we're going to add a lot more stuff over here to actually call the cover from a behavior function. Okay, so let's go now into our attack behavior, because there is a lot of stuff to add. So we have our variables. If we have find cover positions, okay, we need to list one for the cover positions that we currently have, and we need another list so that we have positions that we know we can ignore them, because I do not want to iterate all the time to find positions, because we have three lists, we have three lists. I do not want to search inside three lists to see that every position, if it's a viable position or not. So that way, when we find a cover position that does not have any position that we can actually use, any cover position or any cover slot that we can actually use, I wanted to add it inside this ignore positions list. So the next time I'm going to be searching for a cover position, if a cover position is inside this list, then we are going to simply ignore it. Now, object distance comparer is an eye comparer. We have used this before in the Assassin's Creed videos, but we're going to see it once more over here. Now, the cover base is the current cover position, so that we know where we're actually going. So if we leave that position, or if the unit die, then we can simply reset its occupied state. Okay. Now, maximum tries is how many tries the unit is going to actually search for a cover position. Okay. Because if we not add something like this, is the unit will always be searching for a cover position, and it's going to stay. If it doesn't find any, it's going to stay in an infinite loop. Okay, so with this way, if I disable my cover position, now there is no other cover position anywhere. Okay, so if I hit play and change the enemy unit, now keep in mind that for the cover position to work, they must have a target first, otherwise you're going to get a null reference. Okay, now I'm going to change it to cover, and you will see if we go to the console, and I'm going to use it frame by frame. Okay, first frame, current tries +1. That means it's already tried to find cover position once. Okay, twice, 3 times, and the fourth is going to give us, is going to change his behavior on the fifth, anyway, on the fifth frame, and he's going to, we're adding a debug log that says we have reached the maximum tries. Okay, we change its behavior, so it changes its behavior from cover to attack. Okay, and then it continues. He will fire like it was before. Okay, now on later paths where we are going to actually make more combat stuff, more advanced combat stuff, we're going to make them retreat or go find reinforcements and everything else. We're going to see those stuff on later videos. Okay, no need to do all this stuff over here or right now. Then, so we have our basic variables. Now we're going to write 2 new functions. One is the cover behavior, which is the actual cover behavior, and then the other is the find cover. So let's start. If find cover positions, if we do not have any cover positions, then we call the function find cover. Now before we go into find cover, let's see on the else part of the if statement. So let's say we have the cover positions, then we pretty much know what to do. Okay, move to position, call the function from the character stats to move the position, make him run there, check the distance. Okay, and if the distance is lower than 0.5, stop moving, call the function to stop moving from the character stats, from the enemy AI main character stats, remember our refactoring. Okay, and then change the AI state to attack. So it's what it simply does is goes into behind the cover position, okay, and just attacks. Now, yet again, on a later part, we're going to make him not just straight attack. We're going to create an attacking behavior behind cover. Okay, where we're going to make him. We're going to add suppression on all this stuff and other tactical. You can say tactical behaviors. Okay, we will see all this stuff on a later video. Now, so this is the behavior we have when we actually have cover position. Now, since we do not have cover position, let's see how to find one. The first thing we're going to see is if our current rise is lower or equals, or you can just use lower, doesn't really matter, the maximum tries we set from the inspector. Okay, now if we haven't found any cover positions, now this might be a little bit redundant, but it doesn't matter much anyway. Okay, the first thing we are going to do, and this is important, that is this over here is the first thing. We have the find cover positions, we want to turn it to true. We add to the current tries, okay, so we do not forget to add it later. And then we create a new cover base, or a new variable for a cover base, which is this is what we're actually going to return. and we initialize it as a null. We want to use the distance from the target we are attacking, so we create a variable to do so, and we use vector3.distance to find from our transform position to the enemy target transfer position. Okay, so we make sure we're not using any cover positions that we have previously used when we run this, if we have previously run this logic, then a cover position list will probably be populated, but we do not want to use any cover positions, because if the previous list was populated over here and we are over here, then the cover positions we're going to have inside that list is going to be around here and not where we want them to be. Okay, so we use cover positions.clear to clear a list of positions. The target position. Okay, where actually is the position of our target, and then we use collider, an array of collider, where we use the colliders, and we use physics.overlap sphere from our transform position to a radius of 20. Now we use that on not the previous video, the part before that, where we actually where we see inside our search behavior we use that, and it was around here. Okay, this is the exact same logic. Now the radius, you might want to change that to be the same as the view sphere, or what works for you. Okay, now pretty similar to this from the search behaviors, we find all the colliders that are in a radius near from the position of our unit. Okay, with a for loop, then we search each collider if they have the component of cover position. Now if we find a collider that has this component, our job is not done pretty much, because as we said, we need to add some logic to that, and we say if the collider we found that has the cover position component, if his transform is not contained inside the list of ignore positions, then we continue. Okay, otherwise it just ignores and goes to the next collider and to the next collider. We need to check the distance towards the candidate collider. Okay, the distance from our position to the candidate cover position. Okay, again we use vector3.distance, okay, from our transform position to the candidate collider position. Okay, now we have a debug log so that we know where it is, and then we say we need to check the distance, if the distance to the candidate is lower than the distance to target. Okay, so if that is if the cover position is closer to us than what the enemy target is, that probably means that the cover position is a viable position for the enemy to go hide behind it. Now of course this straight up looks the distance right away, and it doesn't take into account the nav method at all. Okay, so if you want to be more picky than that, you can actually create a path towards the cover position and a path towards the target, and check the distance of the path instead of checking the distance between two transfers. Okay, now that will be of course more calculation heavy, but you might want to use that. Okay, for us and for the purpose of this video, this works fine. Okay, so if it's the distance to the candidate cover position is closer than the distance to the target, then we add the hits transform to the cover positions that we already have. Okay, simple enough. Then if our cover positions.count is greater than 0, okay, the first thing we need to do is sort the cover positions, because we do not care if we have a lot of cover positions, okay, like that. Okay, we shouldn't be concerned, this unit shouldn't be concerned that there is 2 other cover positions over here. Okay, we only want to take the cover position that it's closer to him. Okay, and the way we do that, we have all our cover positions that are inside our sphere radius. So we need to sort it, and we sort that by distance. So we go down here, we have a public void sort positions. This takes a list of transforms, okay, we call it positions, and then we create our iComparer class. Now this is a class that takes from the iComparer, and we need to pass the component of transform. We need to pass the reference object, which is of course a transform, and then there is the object distance conferrer, the constructor, okay, that we also pass a reference, and then the reference object will be the reference, and this in turn calls the compare function. Okay, and what it does, compares two transforms, and the way it compares it is by distance. Okay, so you have distance to x, distance to y, and then it will return either -1 or 1 if, well, it compares them, but doesn't return. This will return if you want to use that, but the way that it uses this, it actually sorts the position. Okay, so this is the list, and it calls the function to sort it, and you need to pass the iComparer, and we use this iComparer. So we basically sorts our list based on the distance. Okay, we have done this before, so let's see. So we sort a cover positions list, so we know the one that is closer to us is the first entry that we have inside our cover position list. Okay, so we store the variable, we store it over here in variable. Okay, but we also need to validate that this position is actually a position that we can use. Okay, so we need to find the direction to target, and that is the target position we find over here, minus the validate position transform.position. So what we basically are doing here is, okay, we find if the enemy is in the front or in the back of the cover position. So in turn, with that we know which positions to take, if we are going to take the slots in the front or in the back. Okay, so we need to find the direction of the target from the candidate position. Okay, and then we need to find the forward of that candidate position. Okay, and we do that by using validate position from the transform, and use the transform direction, and we simply pass the vector3.forward. Now, if the dot product of the cover forward and the direction of target is less than 0, that means the enemy unit that we are going to attack is behind us, is behind the cover, not behind us, behind the cover position. So we know that we want to use the slots that are on the back, that are behind the cover position, but we need to also see that they are not occupied. So we use another for loop. Okay, so when we go into the back positions list, and we say if the candidates back positions are not, if there is a position that is not occupied, then the target cover position will be the validate position dot back position. Okay, so if we find an unoccupied if we come over here and find a slot that is unoccupied, then we're going to use that. Okay. Now, if the target is in front of the cover, then we go and say we pretty much do the same thing, but we use the front position list inside instead of the back positions. Okay. And this is how we find the cover positions. Now, this has one flaw though. We might not have cover positions, and if on the position we find, that we actually find, all the other positions might be all the positions, or the positions where we can actually use. They might all be occupied. So, what we do then? We need to check if we come up till here and the return value we want to return, which is the target cover position, is still null. Okay, then we say that find the cover position will be false. So the next frame is going to return to this function. It's going to return inside the for loop, inside the if loop. Okay, and it's going to do everything once again, but it's going to go into the cover positions, and it's going to check if it has cover positions, but it's going to go into the ignore positions list, and it's going to add it into the cover position, and it's going to add the target cover, not the target cover position, the first cover position, the first entry on inside the list. So let's say this this cover position over here is occupied. Let's see it in action. Okay. So he's watching me. Okay. He has a target. We don't want this. We want this one. I'm changing it to cover. His AI state to cover. I'm gonna hit. We're going to go into the next frame, and inside the cover position, you will see that it has the cover positions, and the first cover position that it actually has is this one. Okay, now I have this all occupied, so in turn it searches that there is no viable position for him to take cover behind. So it takes that cover position and it's added on the list of ignore cover positions. Okay, so on the next frame it's going to recalculate and take all the colliders once again inside his radius sphere. Okay, but you see that the first position, it's not the cover position that we have all occupied. It's actually the cover position over here. So in turn, he's going to go over there and take cover. Now, okay, this was pretty simple, I think. Now, if we have a target cover position, then we're pretty much done our job. Take the target cover position and make it occupied, so there's not two AI targets that go on the same position at the exact same time. Okay, and then say the current cover position, return the target cover position. Well, not really return it, just assign it to our current cover position. So next time we want to when we want to add more behaviors to it, we can simply say this cover position is unoccupied, and then and that's pretty much how you find cover positions and you validate them. Now, of course, you can do a lot more stuff, and you can also add ways to prefer which target. So if this target, if this cover position, you want them to add more strength or more cover or armor, if you want to have destructible cover positions and all this stuff, and you want your enemies to be able to choose between if they're going to have if they're going to take cover behind cover position that provides more armor. Okay, or you name it. You can do whatever you want with this. Okay, you can pretty much add more variables over here. Okay, and more calculations, and you can do with this everything you pretty much can imagine. But the other thing that we need to take care of is to make sure what happens if we reach the current rise, if we reach the maximum rise without we can actually search for a cover position. Because as we said, okay, if we let this run all the time, it's going to make the enemy just sit there, okay, and he wouldn't do anything. Okay, so if I comment this out, you will see that they're going to sit just there and they're not going to really do anything. So if we reach the maximum tries that we can try, throw a debug log, okay, and say maximum tries have been reached, change the behavior, and then we simply call the function to say, simply attack. Now on later parts we're going to change this, okay, because we do not want them just straight up attack. Okay, we're going to run some behaviors and some calculations on its logic, and we're going to see if we want our character to surrender or if we want our character to go not surrender, to retreat, to go and find reinforcements, and all this cool stuff you might want to add. Okay, so we will have some pretty advanced and dynamic AI. Now, with that, we pretty much completed this part 2, this part for the cover. Okay, I want to keep things more clear and more, not cluttered up that much as previous videos. So that's why we didn't add it, the decide logic right now. So what we're going to do, because we're going to we're pretty much making some combat behaviors over here. Okay, so we're going to see a lot more stuff like that on next videos. So if you like the video, don't forget to like and subscribe, of course, for more videos. If you can support me on Patreon and you like these videos, then please do. Okay, and with $5 or more you also get access to a Google folder where I have all the scripts, and in turn you help me make more videos, because all this stuff take time, take research, and it's time I could be doing something else. Okay, that makes an income. Okay, and another way you can also support me is by going, or if you want to buy, if you like a project that you see in this channel, you like to buy it, okay, with all the references and scripts and all that ready to go, and pretty much you hit play and they're done. Check also the Gumroad page, okay, and we also have some stuff on the Unity Asset Store. All this stuff are available in links in the description, okay, and then this way you can support me, and I can keep making videos like this, and videos videos that are interesting to watch. Okay, so we're not doing the same stuff all over again. So thanks for watching, and I'll see you next time.